is called implicit differentiation. And it is section 2.6. This 2.7 is the word problems and 2.8 is related rates, right? Yes, okay. If a function is expressed implicitly, it means that there's not a dependent variable that is solved. So for example, up till now, every function we have seen in our class, or every formula we have seen in our class, has been an explicit function. So y equals 4 pi x squared. Okay, it's solved explicitly for y. Okay, this is solved explicitly for y. Notice the one I just wrote on the board, it is not solved explicitly for y. Y and x are kind of mixed together in the formula. And especially when you get into studying surfaces, it's helpful to often leave it written in that form. Honestly, I personally don't really know why in college algebra we focus so much on the definition of a function, because there's lots of times where a curve has some usefulness to it and it doesn't really fit the definition of a function. So if I graph, I can't remember if I have, yeah, if you graph what we are looking at right now, this is what the graph looks like. And do you remember that vertical line test from college algebra? What does vertical line test from college algebra say? If it goes through it twice or more than once, it's not a function. So this is not a function. But it doesn't mean that the curve, doesn't have, it exists, it's there. And at every point there's a slope, except what are 4 points at which this does not have a defined slope? There are 4 points where this graph does not have a defined slope.
Negative 8, 0, 0, 8.
Very good.
8, 8, 0, and 0, negative.
And what is Josh noticing? What points is he reading off?
The x and y intercepts.
Yeah, but why particularly the x and y intercepts?
Because there's no derivative there.
But why is there no derivative there?
The points.
They're sharp
Sharp
points. They're sharp points, okay? So the slope coming from this direction differs from the slope coming from that direction. So there's a sharp point, and so the derivative does not exist. All right, and for this particular function, it happened to, occur at the intercepts. All right, but there were 4 sharp points. All right, but besides those, there is a slope everywhere. So who cares that this was not technically a function? At any point I pick, it has some slope. So what implicit differentiation is about, it's about how to get to a formula for the slope, even if it's not an explicit function. So if I leave this one implicitly, then I take the derivative of both sides. So here my first step would be to deal with that first term. So 2/3 times x to the minus 1/3. And then I would deal with the second term. So it's power rule also. But you have to pick one of the variables to be dependent on the other one. Okay, so your book, and for the most part, any book you look at, you're going to assume that y is some function of x. Okay, y is dependent on x. So because y is some function of x, right now we just don't know exactly what function it is. You have to look at this as a chain rule problem. Okay, y is some function and it's plugged into a 2/3 power. So I took the derivative of the outside function, okay, this was my outside derivative, but then the chain rule tells us to do what once we take the outside derivative?
Multiply by the inside.
Multiply by the derivative of the inside. So either write times dy dx or write times y prime. It doesn't matter which one. You just need to recognize that y is some function of x. So it is a function plugged inside this 2/3. And so the chain rule says, once you get done taking the derivative of the outside, multiply by the derivative of the inside. So this is derivative of the inside. And then you take the derivative of both sides of the equation, no matter what you have on both sides. In this case, the derivative of 4 is going to be 0. Okay, and then this is what we really want. We want this. We want a formula for that. So once you take the derivative of both sides, then you clean it up so that you have solved for the dy dx. So for this particular example, I would have 2/3 y to the minus 1/3 equals negative 2/3 x to the minus 1/3. Oops, sorry, I have my dy dx over here. Okay, I'm trying to solve for this, so I moved this over, and then I'm going to divide by that. Cancel, and the negative exponents, we might as well flip them, so we might as well rewrite this as that. Okay, so if I knew a point on the curve, if I knew a particular point on the curve, I could then plug the y and the x on the curve into that formula, and it would tell me the slope at that point. A lot of times it's not real clean to, points that you get, because these formulas are usually not. Like right now, if I tried to find a point that's on here, I'm probably going to struggle a little bit. But the easy ones to find are the places where the derivative didn't exist. So I'm not necessarily going to find them. Okay, so that's the premise of implicit differentiation. So why don't we say for Thursday, I think it would be a good idea for you guys to have some regular independent mini test, like quiz, okay? Whereas like your group quizzes are kind of more exploratory, but a regular quiz on derivatives on Thursday, okay? And so, you want to practice your rules. So I gave you your flashcards, so that would be helpful. You also have that big sheet of like the 40-something problems. I thought I posted, I gave you the solutions, didn't I? Didn't I staple them to it? No? Okay, I'll post them on